Hello, this is a quick introduction to Lab 3 on Bash. Today the subject is really pipes, Linux pipes, but first what I'm going to ask you to do is to play with manual pages. So man is the command for getting the manual page for any command on Linux. I'm going to show you another one. So the way it works is you just type man, stands for manual, and you want to learn about ls. What are the different options that it supports? So it's going to say ls list. So always at the top you have what the command does, and then you have all kinds of options you can use to change somehow the way the command operates. One that we're going to look at today is -a, means all, list all the files, and -l, which is down here, which means use the long listing format. So anyway, so man will give you information about commands. And when you're in man, you're in a browser. You're browsing a text file. So in order to get out of this mode, you have to do like you did with less, the command less. You type q. Q brings you back there. So you can also, if you want to know if there are commands that deals with hexadecimal, you can say man -k for keyword hexadecimal. Is there any command that somehow deals with that? So I have a lot of commands listed here, but I should be able to see one that I know called hexdump. This is what we've seen in class. All right, so you're going to play with that a little bit. And another command that you might like slightly better is info. So for example, grep is a very powerful command for searching. If I want some information on grep, I can say info grep. I'm going to make this window bigger so that I can see things a little nicer. All right, so again, I'm in the browser window. If I type Q, I get back out of it, back in, info grep. What info does, which is nice, is that it has hypertext. So I can go to usage, for example, and by moving the cursor, and then press usage, and then I'm going to see examples. So info is slightly more user-friendly than man, but you're going to play with both, and both of them are available to you. All right. Now let's go to pipes. So I'm going to switch to my iPad to illustrate what we're going to do here. So if you look at the what I have here, this is my view of how the commands work on Linux. You have a command here, an application, and this one will look in my directory for all the files that have a .asm extension. So these are the files. And it's going to take all of them, find only the ones that are .asm extension, and it's going to send that to the screen. So that's the computer screen, which that's also standard out in Java and in all computer science related languages. So standard out the screen. So that's the default for a command to output to standard out. If however, sometimes I may want to do something different. So here is another way of working with the command. I could do my I want the marker here. All right, go back to marker. I still want to do that, but let's assume that in all the ASM files, I would like to isolate just the ones that have hello in their names. And then there may be several. So, and it may not be the first word, it may be just there's hello somewhere. So what I'm going to do is send the output of this file. Instead of sending it to standard out, which is the default, I'm going to send that to another command, grep, and I'm going to ask grep, in whatever is coming to you, the text that is coming to you, which happens to be the name of files, look for the word hello. And grep will do that, and we'll send that to standard out. So this is a pipe here. And in Linux, a pipe is referred to by a vertical bar. All right, so let's take a look at what that means here. If I do ls everything.asm, I'm going to get a lot of program. Do I have an hello? Yes, I do have a hello here. Let me create another one. I'm going to cp hello.asm to my hello asm. So I want to be able to find both of these files. So now if I do an ls, everything asm, I see I have this. I would like Linux to give me just these two files. So what I can do is say ls give me everything that is an asm file pipe. So that vertical bar means take the output of this command and send it to grep and ask grep to look for hello, and -i means irrespective of the case, lowercase or uppercase. And sure enough, no, I have just two files, hello and my hello program. So it was able to find the word hello in the file names and just give me that too. So what is important here, and what we call a Linux pipe, is this little vertical bar here. It takes the output of the first command and passes it on to the next command. All right, so I'm going to ask you to play with that a little bit and then introduce a new command, which is word count, WC. And I'm going to ask you to play with ulysses.txt, which you should have in your account. If you don't, you can get a copy of ulysses.txt again, and that will bring it into your account. So don't worry if you don't have it. So let's try it. Word count, ulysses.txt. All right, gives me just one line, but it says there are 33,000 lines of text in ulysses.txt. Actually, 268,000 words and 1.5 million characters. So very, very quickly, WC was able to open the file, read it, and count everything. Counted the words, counted the lines, counted the characters. WC, if we do a manual page, we see that it has several interesting options. -l will give you just, we can ask word count, WC, to return just the number of lines. And we're going to be using that a lot today. So let's try that. Word count -l ulysses.txt. And so it returns the name of the file, and it returns how many lines there are, 33,000 lines. All right. Now we're going to apply this by trying to count the number of files in a directory. If that's something that we're interested in, we absolutely don't want to count by ourselves. We should make the computer do that. So etc is a directory that is used by Linux, where it puts a lot of system files, and there's a lot of them here. And it's listing them in 3 columns, but actually I could force it to list everything in one column by doing ls-1, and now I have all of them. And assume that I want to know how many such files there are. Well, what I can do is ask for the 1 column version, or actually just ask for the list of files, and it's going to give them to me one at a time. And I'm going to say word count, pipe this output through word count and count only the lines. 281. That means that I have 281 files in my directory /etc. Okay, so that's what I have here. Challenge 1. How many users are registered users on Merax? Well, on a Linux system, users are typically in /users. So if I look at /users, I'm going to see a lot of names. These are people's names. Is Thiebaut there? I don't know, actually. I haven't checked that. There should be a better way for me to do that than to look for it. No, I'm not there. I'm on another system. So, but anyway, so that I got by asking ls to list all the inputs into the directory users. For Linux, a user is simply a directory in that directory. So these are all the different users who have an account on our Merax system. The student accounts, so 231A different dash something, they're kept in a different place. So student accounts are not kept here, but here are kind of the regular users. If I want to know how many there are, I repeat the command and I pipe the output to word count -l 2,109 users. All right, how many molecular bio? See if I do ls let's see, molecular, oh, small bio. Huh. Users. Oh, I'm looking in the wrong directory. Users. Okay. I'm having a problem here because when I'm asking the ls command to list me these different files, if a file is a directory, it's going to look inside that file, that directory, to tell me what's there as well. But all user accounts are protected. I cannot, so therefore I'm getting an error message. And if I'm getting an error message, then the output doesn't go to standard out, goes to standard error. And so if I were to do this, word count minus L, it would say 0. It cannot count anything because all these messages here are errors, and errors do not go to standard out. So therefore, piping the output of this to that, I'm going to ask word count to count messages, but since all of the outputs are to the standard error, word count is going to count 0. So I have to do something different. So here, one thing that we can do, I'm going to give you a hint on how to do that. You have to say ls minus d. If you do that, it's going to list, the minus d says just list a directory and do not go inside. Do not try to go inside the directory to list whatever is there. I just want the name. So in this case, I can list all of them and try to figure out a way to count that. So you know, I'm going to give you a hint. It's going to be 64. But try to make Linux tell you the answer. I'll make it print 64 by using pipes. Another thing that we could have done, there's always many different ways to skin a cat with Linux. And the other way we could have done that is to list all the users in the users directory and then grep for just mobile in a pipe. So try that, see if you can get the same number. And then you can word count that. So it's a double pipe, actually. We're going to play with grep. So we're going to look, so Ulysses, if you haven't done that, again, get copy Ulysses, you can get a copy of it. If I'm grepping, minus I means irrespective of uppercase or lowercase. Mulligan, who is the main character in Ulysses, if I grep for this word in Ulysses, it's going to give me all the lines that contain the word mulligan, either once or twice or more, but as soon as it appears once, then that's it, that line is going to be listed. How many such lines do I have? Can you guess where I'm going to go? Yes, we can pass that to word count, like so, with a pipe, and therefore we're going to count all the lines that contain mulligan. And again, this is going to be very, very fast. All right. The grep minus v is useful. Let's assume that in users, I want to count all the users that are not mobile. So ls users, I have all the users, including these guys here. If I don't want them, I could say list everything in users, but grep minus v mobile. Minus v means except. I want, if the line contains this pattern, I don't want it output. So if I do that, I'm going to get all the users, but not mobile. Not going to be there. See if I'm actually would be around here if they were here. So the grep minus v is very useful for eliminating lines that contain a particular pattern from your output. Okay, so if I do that and if I count, then I should be able to word count minus L. There are 2045 users that are not mobile in my directory users, in my folder users. Okay, here I'm asking you for all the files created in October that are in Etsy. if you do ls minus l etc, it's going to give you the long listing. So minus l here means the long listing. So it's a modifier, it's an option for my command ls, and it's going to list the long listing. And if you grep for September here, you should be able to find the files that were created, or in October, that were created in October. Should be easy to do. This is trickier. How many users have a name that starts with the letter Y on Merax? So ls users. I want to just the people who are here. See this YN all the way to YJU62. I'd like to count how many such accounts there are. But I don't want, for example, this account that has a Y in it, but it's not the first letter. I just want the accounts that have only a Y as the first character. Okay, a little hint for you is that caret is a character that you can use in a pattern. For example, if you grep caret, my last name, into some file, you will see it's not going to be there. But if it were, it would list only the Thiebaut that would appear at the beginning of a line. So caret here, you may have seen that if you've taken theory of computation. It's a symbol in a pattern when you search for a pattern that indicates at the start of a line. So it's going to help you with challenge 4. Working on the logs. Okay, this is something that is more useful, and I think you're going to see see why the commands that we're looking at today are interesting and could be useful when you're doing some analysis of maybe a break-in in your computer system. Computer systems that are on the internet are people try to break in regularly, all the time, every day, every hour. And so what you can figure this out because a Linux system will take a log, will keep a log of pretty much everything that goes on in the system, including when people are trying to log in. This is what the auth log is, authorization log. So let's take a look at it. You'll get a copy of it, by the way. Get copy auth log, and that will put it in your directory. And at the end of the lab, I'm going to ask you to get a copy of authlog.1, same thing. So if you do less authlog, let's make this bigger so that we can see the whole thing a little more easily. What you have is basically on that particular day, every time, at that particular time, the user root, so let's take a look at this one because that's me. On September 13 at 8 o'clock and 1 second, I opened the session using SSH or PuTTY. I connected to my server, user Thiebaut, and then at 8 o'clock and 11 seconds, so very shortly, very quick connection, maybe because I was transferring a file and that was done very quickly, then I closed the session. So every so often, though, there will be authentication failure, for example, or failed password. This is indicative of somebody who's tried to connect to the system, to my server here in this case, and was not successful. And the person used the account or the account name Vivek and was doing this from this particular IP address. So Linux system knows what computer was used in order to try to connect to my system, and unfortunately the person didn't know a password, so try this. Usually they try all kinds of accounts. Anyway, just for fun, let's try to see where this particular computer was located. So I'm going to go to Google here. So where is, oops, not mobile, this. Okay, 61, 172, 270, 252. Okay, so these numbers belong to, Let's see. Let's see, I should get somewhere else. I saw something interesting. Blacklist China, so 61, 172, 250, 270, Belgium here. SSH authentication failure. So very likely somebody in Belgium was trying to connect and couldn't. It doesn't mean that the perpetrator or the hacker was in Belgium. Could be somebody sitting somewhere else, could be in the States, and had access to a computer in Belgium, and from Belgium was trying to connect to the computer. So that's what these numbers are. So I'm going to ask you to do some kind of a research of failed passwords on this file. So what is it that I'm going to ask you to do? Let's see. Look at the very cryptic. I'm suspecting that people are trying to connect. Yeah, so look for failed password. How many recorded failed logging lines were logged by people other than user DTAB? Yes, anybody, because it's possible that I tried to connect and didn't remember my password or mistyped it, so there would be a failed password for DTAB, but I'd like to know how many such attempts. So a way to do that, the quick way would be to do a grep for -i failed password in authlog. And if you do that, you should get all the lines that have failed password. So what you need to do from these lines, you have to remove the lines that contain DTAB. Okay, and that could be me trying, and then you count how many such lines there are. Okay, and then you're going to be ready for the Moodle quiz. So I think that's enough of a good introduction for you to do the lab number 3 on Bash. Okay, good luck.